In the lab space, if if you haven't seen a lab guy make a denture in the digital realm, it's pretty cool, right? I tell technicians, this is where you can create the denture tooth and teeth of your dreams, right? And then set it like you would normally set it, but you're just doing it with, a mouse and a keyboard now. But same mold, same teeth we've always known and loved, but we're able to scale them. If you notice, I scale that case down just a little bit. Like this mold might be perfect, but if it was just a little bit smaller, it'd be even more perfect. And we just don't have that kind of freedom when we're using carded teeth. But being able to do this in half the time, that's really changed our game as far as the denture workflows. And this just translates over to the implant. Matter of fact, I use the denture workflows quite often in an implant case because of the tools it gives us and the ability to be able to be so varied and so, perfect with it. And it's no doubt, absolutely no doubt, that a digital denture is a better fitting denture. And with the latest materials and technologies and printers and mills today, it's stronger than what we have always done with acrylic. So there's really no reason not to do a denture digitally, and that is a very common trend. But with implants, right, if we see this patient in the chair and we look at that patient, first thing I'm thinking is that those are really good ridges and we could do some really nice dentures on that. But quite often our patients are coming and saying, I saw this thing on TV about getting teeth in a day. Can we talk about that? And so what we want to do is we want to talk about all the options, right? I'm not a proponent of saying there's only one solution, right? All on X is a great solution for some people, some folks, some circumstance, but it's not the only solution. I will always say that traditional dentures are an option, but overdentures are still the most popular implant restoration. And but fixed is certainly growing. And when we look at All on X, we have lots of tools and lots of parts and pieces that we can use. Is why we're here today. And then there's an alternative that we don't hear a lot about, and that's the fixed removable, or what's the conus application. So it's all about options to me, right? And I want to know, where the patient's been, what it is they like about what they have, what they don't like. And the thing we have to remember, though, is these categories, right? A full arch removable, right? And this is your typical DESSLoc or locator or falls attachment, or maybe even a bar with a couple of attachments. These are primarily tissue-borne appliances, implant supported, implant retained, and tissue-borne. There's still some tissue contact, and we have to have that for these overdentures. By far, the most common implant edentulous restoration out there because they've been so successful. Nothing wrong with that. On the other end of the spectrum, the All on X is something fixed, right? And it's 4 to 6 implants that we're going to bolt something onto. And it could be varying things that we choose to bolt down to these 6 implants. And so it's really all the same in that we're starting with 4 to 6 implants. We're putting something maybe on top of that. Then we're bolting some sort of appliance on that. And it could be zirconia, it could be PMMA, it could be a metal substructure with something on top of it. But at the end of the day, it's something that's bolted in. And these are completely implant borne, right? There's really no tissue borne here. These are totally implant supported, implant retained. Everything is implant. The only people that take them out would be, the dentist. And this third option, this was my what else you got, was the conus. This is the one that's also totally implant borne, but it is a removable appliance. So when we need a saddle due to bone loss, or we need lip support, or affordability, this is about half the price of an All on X fixed restoration. Conus has been my good third option. So having options to me is key. And I think we look at the circumstance and we try to decide, what is the patient's goals, right? What is it that they have a need for? What is it that they have that they don't like? And, quite often I will hear an 80-year-old grandmother say, I don't mind my denture that much. I just wish it stayed in better, right? That's an overdenture conversation. That's a DESSLoc conversation. But then a lot of folks come in and say, I'm tired of teeth that I have to take out every night. I'd like teeth to be teeth again. Is there something we can do there? And so that's an All on X conversation. So we talk about their desires and where they are. Then we have to think about, what is it they can afford? What is it that they would like to be able to go through, right? And you start explaining the treatments. And price is always a question. Putting the implants in where they need to be is always certainly part of the factor. This is a case that started out as an All on X, but we had to convert it to a conus because of lip support. And if you notice, your lips out a little bit, but what really was happening And her unhappiness was that every time she smiled any bigger than this, right? Big smile, big laugh, her upper lip would actually get stuck between the restoration and the ridge. And she'd have to reach up real quick and pull it down. She didn't like that. And I don't blame her. And so the initial reaction was, let me just add some more pink up there to stop that. But then we can't do that because it's already hard enough to clean. And if I had a flange, then she certainly would be able to clean it. So that's why we had to switch this to a conus, something she could take out, but we were able to give the flange for the right lip support. So, it's not only whether they want removable or fixed, but the dexterity is an issue, right? And dexterity in a lot of different ways. If it's an all on X, are they able to clean it, right? They have to be able to get up under there and clean it. Or if it's an overdenture case, how much struggle do they have getting it in and out? Because, there are things we have to think about when we're planning a denture case or an implant overdenture case or implant fixed full arch case. And primarily with fixed or the conus fixed removable, we have to think about this AP spread. And that relates really to how far back we want the teeth to go. And so quite often I would get a case and, we need second molar occlusion here. I said, well, the AP spread is not big enough for that. And see what it is. We draw a line through the most anterior implants, the most posterior implants. We measure the distance between those two lines. We multiply that by 1.5. And that is a maximum
on full arch.
That is the maximum we can go past that posterior implant. So there's a limit to that. We need to plan for that ahead of time. So this is probably the bigger challenge we have, and it's vertical space. I think we see this more often than anything, not having the clearance. And so there's always that conversation, how much room do I need? And the best rule of thumb is to measure from the surface or the occlusal of the restoring bone or top of the tissue to the occlusal plane or the opposing dentition. And 15 is always a good goal, right? I'd love to have 15 millimeters of space. And we're talking about the molar bicuspid area. If I could have 15 millimeters of space, there's not many restorations that we can't do in that amount of space, right? So if you list all the different possible restorations, can I do all these things in 15? Absolutely, 100%. The question then becomes, what if I only have, 12 or 11 or less than 9, right? What can I do in those spaces? It's the list gets shorter as the space gets shorter, right? And I can tell you that the average is 12. And with 12 millimeters of space, doing a hybrid bar is pretty tough. Pretty hard to do a conus, to do a DESSLoc, a locator overdenture type, and certainly can do crown and bridge. So vertical space is always a challenge. So when we think about, okay, which way we're going to go. So let's talk about the different methods. Let's start with the most common, and that's the DESSLoc. The DESSLoc is a locator clone, right? Everybody knows locator. DESSLoc is an absolutely 100% clone. They are totally interchangeable. So you can use either one and the parts associated with each. The nylon caps are the same, the metal housings, everything's the same. But what I love about these attachments is the height requirement is very small. They're very predictable. They're easy to replace, right? They have, good features. What the DESSLoc, this coating they've proven it. There's 2 good studies done in Europe that show the tissue is much happier. Really love the torque tool that DESSLoc has created. It really hangs on to that abutment well so that we can get it torqued in. But you can see the nylon caps are the same as we've always known with the other system. We have the same pivot. We have the same angle rotation. I really like the DESSLoc tool a little better than the locator tool. It's a little easier to use in my hands for all the insertion and placement of the parts and pieces. And very awesome little abutment and attachment system. But it's not anything new. We've been doing locators for a lot of years. And again, this thing is 100% compatible. It is literally the same. I remember asking DESS, I said, did you guys get in trouble with locator on this? And they said, well, we worked it out. So not a big deal, guys. It's been completely validated. And I guess the big win is it's less money. So the tools are there. The features are as good or better, right? But the price is less. So why not? So what I've done in a few cases is figured out a way to do it in a couple of appointments digitally. So if you've got an overdenture case, right, and the patient has an existing denture, we can get those implants. We're going to do the planning and get the implants placed, of course. But once the healing is done, then what we're going to do is we're going to take a wash impression, right? And we can do that with the scanner if we want to, but if it's a traditional impression, so be it. But one of the things I like to do if you have an intraoral scanner is to take a wash impression in the patient's existing denture, right? And then we're going to scan intraorally with the wand for those cover screws. All right, we're going to put the dentures in with these wash impressions, and we're going to scan the bite registrations. We're going to take those dentures out. We're going to scan those dentures with wash impressions. And then we're going to put scan post into the implants. We're going to scan that intraorally. So we're going to end up with a scan of the restoring ridge with cover screws, a scan of the restoring ridge with scan caps, a scan of the denture with the wash impression and the opposing, and the bite registration. Right. And so what we can do from that, and then all you do is need to tell the lab or order the right height of DESSLoc abutments, right? What's the tissue height? Just measure from the top of implant to the crest of the tissue. We need that number. And so we order the abutments. We can retrofit those abutments to the existing denture. If the existing denture is worn out and you want new dentures, we can do the same workflow, right? From this data, from that wash impression of the existing denture and the bite, we can use that data to create a digital denture in that location. So at appointment time, it's literally just pick up the attachments, put in the abutments, of course, pick up the attachments with the old denture, or if you ask for a set of new dentures. And so we can literally do this in 2 appointments pretty easy after the implant's replaced. So I like that workflow, but if the patient wants something solid, right, the workflow is a little bit different. We all know this workflow. The implants are designed and placed, and if the posterior implants are angled, then we have to do some angle correction with some abutments and maybe put some MUAs, multi-unit abutments on top of it, and then create the restoration and that screwed to the multi-unit abutments. There are some workflows where we can screw directly to the implants, but in most cases, we're going to put some type of abutment on top of the implants. And that's the typical all on X. And, every implant system has some version of this. But the nice thing about that DESS component is they make these MUAs for any of the systems. And so it's kind of a generic, widespread ability to use. We just have to know what implants it is, and we can order the parts we need. And all on X, really, we haven't changed our theory, right? We used to make them with flanges, but we learned pretty quick that patient's not going to clean them with the water pick and super floss. So we make most everything convex now or off the tissue. So cleansability is better. And, it's a lot of zirconia restorations being made, whether it's a solid zirconia or in like this example, a zirconia frame with some zirconia crowns. And the thinking here is just less bulk for the framework. And hopefully that if anything ever has to be replaced or restored due to fracture, it's one of the crowns and not the whole framework. Zirconia is tough. There's no doubt about it, but it is the most common out there at this point. I think there's a lot of promise with some of the new high strength polymers. I started doing some of these out of this like Trilor material. So instead of a zirconia frame, a Trilor frame, and then zirconia or maybe lithium silicate crowns on top of that. Or in rare cases where I need the utmost of strength, the bottom right case would be a titanium frame that we've used Mio or some other colored composite or ceramic to give it the gingival color, and then the bridges were just zirconia bridges. Again, thinking that if anything fails, we just have to replace the bridge. So let's talk about DESS for a second and what they can help us with in all these workflows, right? If we're doing an all on X, then we're going to need some sort of abutment, right? We're going to use screws, right? And we're going to need scan posts. And I think DESS has done a marvelous job, right? The top of these MUAs are the same across everybody's system, right? So they've done that. But, obviously it's got to fit into different implants. So over 30 systems of multi-unit abutments options. I've not found one I couldn't find a multi-unit abutment for yet. Most every implant I've had to restore or help cases with, we've been able to find the pieces. So that's an option, multi-unit, tie bases, and then the screws we use. So the digital workflow is pretty simple, right? We're going to start at chair side and we're going to put a scan post in. and we're going to scan it, right? And that scan is going to go to our laboratory. Now, it could be a traditional impression, and the lab's going to use a traditional impression with analogs and create a stone model. But then at that point, they're going to put it in the scanner, and it becomes digital there. So now we're in the full digital realm, whether it's we start from an intraoral scan or we start from a model scan. And so the softwares today give us full capabilities of being able to design what we need to design over this data. And then we use CAM technology, both software and hardware, to recreate our designs. It's that simple. And the nice thing about this digital technology, it's consistent and it's accurate and it's controllable, right? It's repeatable. And so I wouldn't want to do it any other way. I very rarely, right, have poured a stone model in the last 4 or 5 years. It's because of the digital technologies. So with digital technologies, right, if you're going to do something in the computer, you've got to have data, right, the scan from the dental office, and you've got to have libraries, right? If I say, well, I want to use a DESS tie base on this case, well, I need the library of that tie base in my software. And nobody's done it as good as DESS here. These guys have uploaded almost everything you can think of into the libraries, both for 3Shape, exocad, and even dental wings. So their libraries are comprehensive, and they're the easiest I've ever found to get at, right? They're just directly on their website. You just go to their website, go to library files, you download them, you go into 3Shape and you import them in, and boom, you're ready to go. The next time when you start that case, right, the libraries are there depending on what part you pick. I'll show you a little bit about what this looks like. So, we've got a scan, right? I've got a scan post with a DESS scan, and getting these libraries in and being able to, utilize these scan posts and utilize the libraries for the scan posts just makes everything digital, seamless, consistent, predictable. And so it's very simple. I mean, you can see all I'm doing here is lining up the scan post scans to the library file I have now installed in 3Shape. And, and then we just verify that we have the angulated hole checkbox, so that we want to put our holes in the right place. And we'll talk about these abutments in a second on how we're allowed to do that. But pretty cool and very simple. So it all starts with a scan body, right? And I absolutely am a huge fan of the DESS scan bodies. Number one, they're titanium. They're not plastic, right? They have this coating, this zirconium nitride coating, that it's easy to scan, matte finish, great color. I use them both intraorally and on models, and it is super, super easy scan post. You do not need a tool for these scan posts, right? We put them in with our hands. There's no hole at the top because of that, right? So it literally, we go in, we spin it around with our fingers until it drops, and then we tighten the top until it has a real noticeable click. It has a tactile click when it's fully engaged. And so it's a very simple, very fast scan post. Its design is, these set flats and sides and corners, very, very cool. One cool thing about the screw is that you unscrew it out of the implant, but then you pull it up and unscrew it again, so it fully separates, right? So when we going through the autoclave, we make sure that it gets really clean, so we can use this thing over and over again. So the shape, these points and flats, it just really picks up on a scanner really well. Again, they make these for every implant out there, and so it's very cool. So while I'm here, let me talk about DESS and something else that they've done. This scan post is great. I'm not sure that I ever need anything else, but there are lots of scan posts out there. You may have 4 or 5 different ones in your office. One of the cool things that DESS has done is they've looked at all those popular scan posts and they've digitized and put those to all their libraries. So if you're using, say, a Straumann scan post, right, and you want to order a DESS part, you can still use your Straumann scan post because they've connected those libraries. I thought that was a pretty spectacular thing that they did. Occasionally we'll have one that's really deep, right? In the scan post, I'm not seeing enough of it to get a good scan. So they added this thing. This is called a scan extender. It just snaps onto the top and it gives me that much more distance to be able to scan and capture that data really well. So this is a very well thought out scan post. And again, very affordable and has everything that we need to capture the data. All the scan posts come with this neat little tool, right? I call it Carrier, that allows us to get in there, drop that thing in, twist it down. You can even feel it, when you tighten it, you can, through the carrier, you can feel that click. But it is plastic, right? It is PEEK. So at some point that thing's going to wear out, but they have an alternative. They have the metal one that we could use. So tighten it down, snap it off, and start the scanning. So once we've got the scan, then we have to select the abutment. And you're going to select an MUA, you're going to select a tie base. Again, plenty of options here. And I love this phrase, your workflow, your choice, right? My workflow, my choice. What do I want to do here? And it could be, a straight abutment, right? These have been around for a long time. There's nothing wrong with these. For an all-on-X workflow, right? Not the ideal, but maybe we need something like this. Another cool thing about their abutments, the screws that come with them are matched to your system. So if you're used to a specific screw color for all your different systems, that's what DESS has done. So they call this smart switch, because not only is the color the same, but the top is the same. So if you have a Straumann tool, the screws that come with the DESS abutments for a Straumann abutment are geared at the top for your Straumann tool. So whether it's a multi-unit or a tie base, right, you pick, and then you pick the screw that you want. And we can talk about this, right? The one on the right would be direct. There's more of that being done where we're screwing directly to a tie base instead of having like a metal cylinder or a tie base up inside that restoration. And they have a really cool screw for that too. So the angle base is the brand name. Angle tie base is what I was calling it here, but it's the brand name is called angle base. It's very cool. It's this has that same zirconium nitride coating. Lots of anti-rotation. Of course, they make it in a one piece to go directly engaged into hex, and one that goes over a multi-unit abutment for the non-rotation cases. But what's cool about all of these tie bases is that we have up to 25 degrees. So if we go back to 3Shape and we're making our restorations and we want to put the screw hole in a better place with this tie base, which is a stock part, right? And in a lot of systems, you don't have this freedom, right? The screw hole would be straight up and down, but here we can go up to 25 degrees, which is going to correct a lot of mistakes, in implant placement due to, what bone we have and where we have it. So I absolutely love that aspect of the tie base. This is a pretty unique tie base they have called a Ellipti-base, and where it really comes into play in those narrow areas, like for anterior cases. It's, I think, about 20% less width, but you can see it has that same coating. But because it's elliptical, we're able to tuck this thing into spaces where we can't put the standard one. Yeah, 22% reduction in size, but the same cement area. Don't have 25, but we have 20 degrees in this narrow base, which is still pretty darn good. So it comes in two versions, right? A and B, and A fits on the corner, B fits on the flat, and that gives you, all the variability we need to get that screw hole in the right spot. So I love this aspect. You watch this case, right? So there's a scan post, and we're in ExoCAD now, and we're looking at, okay, we're rotating this thing around and it's still not lining up exactly right. So we're going to change that to type B, right? Because all it is just a different hex orientation, but that allows us, right, to orient it on the points instead of the flats. And now we can get that thing pretty much where it needs to be, anterior, posterior, or buccal lingually, in that right orientation, so that everything's lined up nice. Love that aspect, right? Two different options, A and B, but the net result is it's just a narrower tie base that we can use in tight areas. Now, here's the big use, right? Everybody uses MUAs. MUAs, multi-unit abutments, whether it's in the straight up and down or the three different angle options you have. And then, of course, you need tissue height options. And the options that DESS has are widespread, right? And some cool things about it, right? Carrier comes with every one. So the carrier screwed into it, right? But the carrier keeps the main screw from falling out. Ooh, that's a big win for me, because that's a struggle we've always had. So once you get this thing dropped in, you tighten it up, then you unscrew the carrier, right, when the screw's safe to stay in, and then we go in with the restoration. And so that's the overall workings of the MUAs. Now, this year they released the MUA Plus. Same orientation, straight and angled, right? And the same 3 different degrees, but they've contoured that emergence profile in a more natural shape. If anybody's ever seen any of my single tooth lectures, you know how a stickler I am for the tissue contour being more natural. And this is a great move to move tie bases in that direction, right? And this is as close as we can get to a customized tie base as we've seen, right, without making it ourselves. But I love that aspect of the MUA Plus. And other than that, the MUA is exactly like their other MUAs. The MUA Plus just means the anatomical correct with the zirconium nitride coating. So plenty of options, plenty of sizes, plenty of heights to do what we want to do with. So then it comes time, what screws we want to use. And like I said earlier, any screw that DESS makes, right, the top, the part the tool fits in, is matched to your system. So you don't have to have another toolkit. You can use a toolkit you've been using with any of the major components out there. And so that's called pure switch, and that's just the top part. And the geometry is exactly the same. You can't tell them apart. They're even making them the same color. So same coating, same driver, same torque value, lifetime guarantee. Watching the technology in the DESS factory make these screws just blows me away. I can tell you that I went into that visit expecting one thing and coming away just completely blown away about the technology, the quality control, the level of inspection of how really careful these guys are doing to make these components for us. So there's not a shortage of testing, right? They continually test things. I think I watched a component go through the factory, and there was at least 8 steps in the manufacturing process that this thing was inspected or tested. And that's done every day, all day. So it's pretty fantastic to know we've got that kind of support behind us. So screws are screws, right? We need screws for various types of restoration. And like I said, there's a big growth in the last few years of direct, meaning we're going to make an appliance. Maybe it's a PMMA prototype, or maybe it's the final zirconia, and we want to screw it directly into the MUA. Whereas in the past, we've always cemented some sort of cylinder, maybe a tie base or a temporary cylinder, into the restoration, so that the screw actually based out or bolted into that metal component. But now, because of cement breakdown or whatnot, there's been a demand and an increase for folks that want to screw things directly. And we've seen things like ball screws and Rosen screws out there for this purpose, and lots of popularity in that. And when everything works, it works. But the challenge is, if you look in the upper right, if you see that small gap between that tapered screw and the wall of the zirconia, milling a taper in the zirconia screw channel is one of the most challenging things we're asking our CAM software and machines to do. So when we don't get a perfect mill of that angle and our screw doesn't fit it intimately all the way around, then that's where problems start to creep up. So DESS approached this a little bit differently, right? And after, again, lots of testing and studies, they looked at where the force of these screws are going and what they're placing on our restorations, and realized the better method is to have the base of the screw, bottoming out onto a flat surface in the restoration, because that's a much easier surface to mill. So we get a much more consistent accuracy of fit between screw base and the actual restoration. And so they've designed the software so that we can mill out our zirconia or a PMMA to receive that screw, but they've thickened it up. This is the thickest I've seen, a full 1 millimeter of thickness of material between the multi-unit abutment and the bottom of the screw. That's going to pretty much eliminate any of that fracture we've seen down there at the base of the screw. I really like this screw for that reason. And of course, they've tested extensively, right? So we're looking at the force, what kind of torque we're getting, and what kind of preload strength we're getting on the restoration. And you can see the red, the negative forces, it's not good, right? That's not where we want them. We want them vertical. And you can see that with the DESS, we're getting a much better preload and the force is in the right direction. So to me, that's almost a no-brainer. So I've gone almost completely in that direction. But in all the other uses, right, it's just a screw we've always known and loved. And they now have a longer one that, answers a whole lot of questions. So let's talk about DESSLoc again for a second, right? Looking at it, it looks exactly like locators. Is a reason for that, because it's a 100% clone. It's 100% compatible with that most popular system, that zirconium nitride coating. Two really good independent studies have shown much healthier tissue around these DESSLocs than the locator and other type of abutments. And whatever's in that alloy is making our tissue happier. That's always a good thing. Comes with a really cool carrier. The tool, I think, is better control, and we're getting a better torque. And the processing kits are identical, and plenty of compatibility out there. So this little hole at the top, that was unique, right? And patients sometimes complain about the vacuum. That's hard to get the seal to break when they're taking out their locator denture. Well, that little hole kind of gives that vacuum a release valve, so the suction is not there. But all the options are for the retentive caps are still in there. The mechanism of the attachment with that pivoting metal housing around the nylon button is still there. The tool to get things in and out, very well designed, very well done. And at the end of the day, somebody could hand you this unpackaged and you really wouldn't notice a difference, right? Except maybe a little bit different golden color. And this coating, though, is a much better coating. The coating on the locator is an anodization. It's just not the same. And lots of studies done on plaque growth and scratch resistance and all that. And that's anytime we can reduce the risk of periimplantitis is a good thing. But we get asked about the hole, right? And like I said, it's kind of there to defeat the vacuum, makes it easier for the patients when they're removing it. The removable inserts, again, work exactly like they've always worked. And, they come in, 1, 2, 4, 1.5, 3, same numbers, same exact nylon. So we don't notice anything differently about it. And I've always said, better tools, better placements. So my favorite tool by far of the DESSLoc is the torque tip. And it has those 3 little fingers that extend over, the edge of the abutment when we're tightening it in, so that it just holds it stabler, and more stable when we get a better torque when the tool is working better. So it's a better engagement, and we can get it torqued in. And we always torque these to the implant, not to the DESSLoc, right? Whatever the torque requirement is for our implant, that's what we torque it to. All right. So we left 15 minutes at the end. I was asked to leave Q&A time, and of course we did miss the first couple of sections. So this is a QR code for my website. If anybody has questions about what my company does, I provide on-site training in dental offices and labs, around the country, around the globe, and that's how you get in touch with me. But let's go back to the questions page.
So if anybody has any questions, you could type them into the chat section, and we will take some of those questions now.
So I do see.
Do you have the cement for the sleeve?
Yeah, I use either the Ivoclar Multi-Link or the Calibra Universal. Those are my 2 favorite cements. If I'm bonding a sleeve to a printed denture or PMMA, not zirconia, then I'll use either Voco Quick Up or the Zest Chairside or the Stern Gold Easy Pickup.
And then Jimmy, do you know the scanning process using the flathead button screw?
Well, there's not really a scanning process. When you select that option in your design software, that data is transferred over to the CAM. And so your machining software calculates that for you. And so when you're milling out your zirconia or your PMMA, it calculates that flat. There is a special burr that DESS will provide when you're doing that you put in, and it's just like a sort of a last touch to stick the burr in to come in and kind of flatten off that flat side. And it fits every milling machine, right, Janelle? The T-tool?
Certain ones that are on the list. From Roland to IMS.
IMS I-Core, VHS.
VHF, yeah. Aurum, XT Sera, Adite, DOF.
Yep. Yes, Zirconzon is a validated zirconia. Is a Zirconzon milling machine on the list?
No, it's not.
Oh, it's not. Okay, but I know there's zirconia is validated in the PNP workflow.
Yes. As we
Well,
grow, we also get, we add more vendors to our list of people who are compatible with our products. So,
yep. So Juan asked the direct to MUA screw as a flat, not a flat bottom, Juan. The underneath of the screw head is flat, so it you know, clamps down on a flat ring inside your restoration. And the conical head would be more like the Rosen screw. And the problem is milling that conical.
yeah, because your milling system does not mill out with the conical an oval egg shape. So the
It's tough.
screws don't seat properly, causing that preload to distribute imperfectly.
Yeah, very difficult. I don't understand that question. Sleeve or without is different. Scan body. No, there's only one scan body. I use the same
Right.
scan body for everything. That's my, one of my favorite things, right? So and people ask me, what is it you like about DESS? Well, I love the scan body for all workflows, right? I love the MUA Plus with that anatomically correct shape tissue emergence. Love it. The gold coating is just a plus for me, right? I don't do many direct to screw applications, but if I do, that flat base screw is great for me. But I'm still a big fan of putting an MUA in there, right? I'm just feel a little better metal to metal, but I'm okay with it if somebody wants it. The DESSLoc, never even heard of the DESSLoc until this year. Never even heard of it. To find a system that's 100% compatible with what I've been doing for 30 something years, but half the price, I'm all over that, right? It's great. With the direct multi-unit, we can angulate 25 degrees. No, with the direct tie base, you can angulate 25 degrees. The multi-unit abutments come in 17, 25, and 32.
So if they go 17 and 30.
17 and 30, two options on the multi-units. The tie base allows you to go up to 25 degrees with the tool.
And if I might just add a little bit, if you're talking about the screw that goes direct to the fixture, the 19069 screw is the one that allows for angulation.
Yes, the flat screw has the top. What do y'all call the top where the tool goes in for the flat screw? That's called a Torx tip. Is that right?
Torx. Yep, yeah. Torx top.
That's what allows the 20 degrees.
Uh-huh. It's an angulated and like an ASC driver with a star type of head.
Very cool.
Anybody else have any other questions? Jimmy, did you want to show your page again? So if anybody wanted to capture a picture of it, we can do that. As always, everyone on here, if you guys do have any follow-up questions regarding any of the workflow, the libraries, or the parts, we are available here in our queue to take your questions, and we can definitely help answer those and help you with the workflows.
And everyone, I was going to mention as well, first off, Jimmy, thank you so much. Great presentation, and we really appreciate you taking the time to share your expertise with us today. Thank you everyone for attending. I see a few more questions did pop up in the chat, so we'll try to answer those. It looks like our associate Key is answering some as we speak. So yeah, I hope everyone enjoyed the webinar and found it valuable and informative. So thank you everyone. And like I said, we'll get your questions answered in the chat, and I hope everyone has a good day or a good night.
Thanks for having me, guys.
Everyone.
All right. Thank you, everyone.
Thanks, Jimmy.